Hello, 8th graders. We are on Chapter 8, which covers trig functions. But before we do that, we have to talk about similarity and right triangles. Now, you may be asking yourself, but Mr. Humphreys, we already did similarity. You're right. But this is going to be used in many, many different problems, and here's how it looks. You are going to be given a triangle. This triangle will look something like this. So let's just go over a right triangle. This right triangle will then have an altitude that makes two smaller right triangles. And I'm just going to call this triangle ABC, and let's call that point D. I'm going to scale this down just a little bit, and what I'm going to do is I'm going to call everything by right triangle terms, so such as a leg, a hypotenuse. So let's look at the big triangle. The big triangle, triangle ABC, I'm going to darken here. But then I'm going to shade in the smaller triangles. So let's do triangle BCD. Let's do that as red. And triangle ABD, we're going to do blue. So what we're going to do is understand that you have three triangles here. The big triangle, the medium triangle, and the small triangle. But they're all right triangles. They all have two legs and a hypotenuse. So I'm going to draw the big one. So I drew the big triangle, the medium triangle, and the small triangle. I've made them all the same position. But we have to make sure we line up the sides that are corresponding. So here's what I'm going to look at. Let's look at the red one. Here we go. In the red one, these are legs. This is the hypotenuse. So to label it, let's look at our short leg, our longer leg, and our hypotenuse. How do they wrap around this triangle? Well, D is the right triangle of both of these. And then looking at the short leg is DB. So the short leg of the red would have to be DB. That means that this point here is point C. Now let's go to the blue triangle, the small triangle. Where's the leg at here, the short leg? It's AD. So that means this is AD, and this would be point B. And that is how you would write them all, going all the same way. So what do we know? We know that they are all similar. So this is a similarity statement. We can say triangle ABC, which is similar to triangle BDC, which is similar to triangle ADB. So they are all similar. All right, we're going to look at this. Consider the proportion A over X equals X over B. You know that when you solve proportions, you can cross multiply. And in this case, if you cross multiplied, A divided by X equals X divided by B, you would get X squared equals AB. The means of the proportion are the same numbers. So here, the means in this case are both X's. And the number is the geometric mean of the extremes. So the geometric mean of two positive numbers is the positive square root of their product. So the geometric mean of A and B is the positive number X. So what it's saying is this. The geometric mean means you're cross multiplying. If you cross multiply, you get X squared equals AB. Therefore, if you solve this, it's only a positive root. And so it would be X equals the square root of AB. So our first example is going to be applying that geometric mean. And all we want to do is find the geometric mean. So all we're going to do for part A, 4 and 9. Find the geometric mean of 4 and 9. All you would do is take X squared equals the product of those two values. And then we know we have to take the positive root of that. So the value of X would be 6. Do this one on your own. Find the geometric mean of 6 and 15. All right? If you did that, it'd be x squared equals the product of that, which would be 90. The square root of both sides would be the square root of 90. And the square root of 90 can be simplified into 3 rad 10, or 3 root 10. So the answer for both of these is in the box. All right, I've scaled these down. And what I'm going to do is assign values to these. So I'm going to actually get rid of these and put up new triangles that I'm going to assign values of their lengths. So here we go. Let's take a look at this before we do anything else. The hypotenuse and legs of each triangle, which they're all similar, have been given just side lengths, random side lengths. They don't mean anything other than, A, B, C. That's leg, hypotenuse. But we've given all of these different letters. So what have we done? We've written a proportion. So let's look at this first proportion. B divided by A equals H, or Y divided by H, which equals H divided by X. Now, why are these both H? Because they're both the same length. Part of the bigger triangle, it's the height. It's right there, the length of CD. So they're both H. Then the next one is the ratio of the hypotenuse to the short leg. So C divided by A equals B divided by H equals A divided by X. And the last one is the ratio of the hypotenuse and the long leg. So this one is the ratio of the legs. This one is the ratio of the hypotenuse to the short leg. These are all of the ratios of the hypotenuse to the long leg. So notice what's happened. Everything in red represents the relationships involving the geometric means because they have the same letter. So watch what happens if I cross multiply only what's in red. H squared equals X times Y. These two, A squared equals CX. And lastly, B squared equals CY. So here's what's going to happen. For every problem, you're going to have many of these. You can either write or draw 3 separate triangles and do all of this work for every problem. Or what you're going to learn next are these are all the shortcuts. Those are the formulas. So let's take a look at what they mean. If we take a look at, we're going to look at the big triangle every time. H squared equals X times Y. So H squared would be the altitude squared equals X times Y. That would mean you take the length of the hypotenuse, and it's each piece that makes that up. So X times Y equals H squared. The next one, A squared, so that's the short leg squared equals X times C. So X is the this part right here that it's adjacent to the A. So A squared equals X times the hypotenuse for the whole thing. A squared equals X times C. A squared equals X times C. A squared equals X times C. Now this one, B squared equals C times Y. We go the other leg. B squared equals Y times C. B squared equals Y times C. B squared equals Y multiplied by C. It's just the opposite of this. A squared equals X times C. A squared equals X times C. B squared equals Y times C. These are all rules that you must know. Now, if you don't know them, you can still write or draw all 3 of your triangles and then write your proportions out and go from there. And here it is. These are all corollaries. The length of the altitude of the hypotenuse squared is equal to the lengths of the segments that make up the hypotenuse. So H squared equals X multiplied by Y. The next one, the length of the leg of a right triangle is the geometric mean of the lengths of the hypotenuse and the segment that is adjacent to that. So A squared equals X times C, B squared equals Y times C. And this is important, you're going to use these so much, but here they are. All right, so our first example is going to be finding X, Y, and Z. You could draw 3 separate triangles out, but we're going to use our corollaries. So when I'm looking at this, what I see is I am giving parts of the big hypotenuse. So that means I can use the first one, which says this. x squared equals 2 multiplied by 10. X squared, the altitude squared, equals the parts of the hypotenuse multiplied together. So x is going to be x squared equals 2 multiplied by 10. Everything must be in simplest radical form. So x squared equals 20. X equals root 20, and sometimes it's called rad 20. X equals, well, square root of 20 simplifies into square root of 4 and square root of 5, which is 2 rad 5. Next one, y. These are each the legs. So what do we know? If we take this one, z squared equals, and if we're looking at corollaries, you should have this in your notes if you're looking at it. Z squared equals 2, that's the adjacent side, times the whole hypotenuse. So z squared equals 2 times 12. Z squared, let's do that down here. Z squared equals 2 multiplied by the hypotenuse of the whole thing, 2 times 12. So z squared equals 24. Z equals the square root of 24, which means z equals, let's see, square root of 24, that'd be 4 and 6, so that'd be 2 rad 6. So we get 2 rad 6. And y. Same thing. Y squared equals the adjacent side, which is 10, multiplied by the hypotenuse, which is 12. That gives us 120, so we're going to get root 120. That would simplify into, let's see, 4 times 30, so it'd be 2 rad 30. And there we go. Here's another example that you, if you want to do, you can. Otherwise, you can skip this part of the video, or you can pause it and try it yourself. So I am first going to find, well, here we have 9, so we know 9 squared equals 3 multiplied by u. So that would be 81 equals 3u. And if you divide by 3, u would equal what? U would equal 27. Next, so I'm going to put 27. V. V squared equals 3 multiplied by the hypotenuse, which is 30. That would give us v squared equals 90. V equals root 90. And that gives us 9 times 10, so 3 rad 10. So v will be 3 rad 10. And lastly, w squared would equal 27 multiplied by 30. And that, what is it, 810? 27, yep. So w equals root 810. That would be 81 and 10, which would give us 9 rad 10. So remember, we're using our rules from last year of simplifying radicals, but that would be their next example. And let's do one more. All right, here it is. To estimate the height of big text at the State Fair of Texas, Michael steps away from the statue until his line of sight to the top of the statue and his line of sight to the bottom of the statue form a 90-degree angle. His eyes are 5 feet above the ground, and he is standing 15 feet 3 inches from big text. How tall is big text? So we want to know that whole length, which means I have to find that piece. So we use one of our formulas, which we know is this. 15 feet 3 inches, well, we need to change that. Let's do, so 3 out of 12 is a quarter of a foot, so we're going to change it to 15 and a quarter squared, that's this, the altitude squared, equals the parts of the hypotenuse multiplied together. So 5 times x. And that would give us what? That gives us, if we solve this, 15 and a quarter squared divided by 5, that gives us approximately 47. So big text is about 47 plus the original 5. Big text is approximately 47 plus 5, or 52 feet tall. Well, and of course, you know what? I said we were going to do one more, but it wouldn't be fun if we didn't throw in a Mr. Humphreys problem. Awesome. So here we go. So here's our problem. We have triangle AIG, and I want you to find the length of AB and BG, knowing that the altitude of the triangle is 8 and the hypotenuse of the triangle is 20. So here we go. We know that a squared, or 8 squared, equals this piece multiplied by this piece. But we don't know either one. We knew the entire length is 20, so we're going to let this side, let's say, be x. If the length of GB is x, what's the length of AB? If we know the whole thing is 20, and this is x, what do we know the length of AB would be? It'd be 20 minus x. So here's how we're going to set it up. 8 squared equals x multiplied by 20 minus x. So now we can solve this. 64 equals 20x minus x squared, and we once again have a quadratic yes. Get everything equal to 0. I'm going to move those over. X squared minus 20x plus 64. I'm going to factor. You obviously can do completing the square, or you may also do factoring. You can do quadratic formula. Any of it works. Let's see. Two values that give me 64. Well, 8 and 8 doesn't give you 20, so we know we're going to be both minus. And we will find out that it is going to be 16 multiplied by 4. Let's see, 40, 24. Yep, that works. So x would equal 16, and x would equal 4. So what could AB be? Well, if AB is x, AB could be 16 or 4, meaning that if AB was 16, then BG would be 4 or 16. So either one could be 4 or 16.